Hence proof. Thus we conclude that the diagonals of a rhombus bisect each other at right angles. Next topic is properties of a square. If all the four sides of a rectangle are equal, then it is called a square. It should be noted that a square is a rectangle, a rhombus and a parallelogram. So it has the properties of all of these shapes. To sum up in square, first, all the four sides are equal. Second, opposite sides are parallel. Third, each angle is of 90 degree. Fourth, the diagonals bisect each other at right angle. Five, diagonals are equal. As a square has all the sides and angles equal, it is also called a regular polygon. Note that a square is a rhombus, but a rhombus may not be a square. A square is a rectangle, but a rectangle may not be a square. And a square is a parallelogram, but a parallelogram may not be square. Now let us take some examples to use the properties. Example number 9. In the adjacent figure, AC and BD are the diagonals of a rectangle ABCD. If AO is equal to 5 centimeter, AB is equal to 8 centimeter, then find the length of the side BC. We are given here AO is equal to 5 centimeter. It is page number. This question is on this example is on page number 45. It may be on your on the other page of your book, new book. So question is ABCD is a rectangle. Here ABCD is there. ABCD is a rectangle. Starting from here, A, B, C, D. The diagonals bisect at O, and AO is equal to given the 5 centimeter. This is 5 centimeter. AB is given the 8 centimeter. Here AB is equal to 8 centimeter. Then you have to find the value of BC. So AB is equal to 8 centimeter. Therefore, now AC is equal to AO plus OC. AC is equal to OA plus OC. So AC is equal to 10 centimeter. So and this is the 90 degree. So AC is equal to 10 centimeter. Therefore, BC is equal to root under 10 cm square, 10 centimeter minus 8 centimeter square by using the Pythagoras theorem. By Pythagoras theorem in right angle triangle ABC, the AB square plus BC square is equal to AC square, or 8 square plus BC square is equal to 10 square. They using 1 and 2. Therefore, BC square is equal to 100 minus 64 is equal to 36. Thus, BC is equal to 6 centimeter. The example number 10. In a adjoining figure, ABCD is a rhombus. The lengths of its diagonals AC and BD are 24 centimeter and 10 centimeter respectively. Find the length of each side of the rhombus also. Find the angle X if angle DCO is equal to 40 degree. As the diagonals of a rhombus bisect each other at a right angle, therefore AO is equal to half of AC. This is the AC is equal to 24. So AO is equal to 12, and BO is equal to 5 centimeter. By the Pythagoras theorem, you can use that AB square is equal to A square plus BO square, and finally after solving you will get the AB is equal to 13. So the length of the each side of rhombus is 13 centimeter. Again in right angle triangle DOC, that angle CDO plus 90 degree plus 40 degree is equal to 180 degree. So angle CDO is equal to 50 degree. This is say the question number 3. Since DC is parallel to AB and transversal AC cut them, so angle X is equal to angle CDO is equal to 50 degree from the third. The example number 11. The perimeter of a square is 40 centimeter. Find the length of the diagonal. Let ABCD be the square with the perimeter 40 centimeter, and you have to find the perimeter. Suppose this is a square. All sides, uh, perimeter of a square is 40 centimeter given. So this side plus this side plus this side plus this side is 40 centimeter. So measurement of one side is equal to 40 by 4, that is the 10 centimeter. Find the length of the diagonal. So now it is the 10 centimeter and this is 10 centimeter. So diagonals will be 10 square plus 10 square and the root, that is 10 root 2. 10 root 2 centimeter. After solving, you get the answer 10 root 2. Uh, Exercise 3.4 is there. Some questions are there. You have to solve all the question. And on page number 47, it is to sum up. The summary is there of this chapter. You have to remember all the points of this exercise. In next video, we will meet. Uh, in next video, we will meet. And the next chapter, chapter number 4, and name of this chapter is practical geometry. Practical geometry. Okay, we will discuss later.